Hey, everybody. Welcome back to another episode of Solar Tech Talk. We are your hosts. I'm Kate Collardson, and with me is Aaron Bingham. We're excited to be back for another episode. How's it going, Aaron?
It's going well. It's a new year. I'm enjoying January. It's pretty chilly out here on the West Coast. So
yeah, it's chilly here too. Out here in Colorado, we're expecting some snow tonight.
Great days for some PV modules to be putting out as much as they possibly can, right?
Exactly. Full sun right now.
Yeah, exactly.
Nice and chilly. So, have you been reading any good articles? Anything you want to talk about?
Yeah, I had a look at an interesting article from PV Magazine. So late last year, they put out a series of articles and zeroed in on some interesting topics around changes to upstream materials. So the materials that get incorporated into every single module, things like wafers that eventually turn into cells. They took a look at what the impact of the trend towards increasing size of those wafers is and how that's impacting module footprint, as well as module outputs. They also looked at some more bleeding edge technology that's being incorporated into modules slowly. And I always mess this word up, but they had a section that was pretty interesting about introducing and continuing to implement perovskite. Is that perovskite? How do you say that one? Do you know?
I think it's perovskite.
Perovskite, yeah.
It's a tricky one for sure.
Yeah, absolutely. So there's a particular section where they zero in on incorporating perovskite technology into cells and
cool.
That's having on cell output. Yeah, it's really cool.
That's great. I'm excited to see some of these new technologies become more widely adopted. It's we've been talking about perovskite for years now, and it's exciting that we're still going down that path, and hopefully we'll be able to see it become more mainstream and see some of the effects that folks have been talking about all this time.
Yeah, and in other parts of the article, they look at other trends that are related to PV, such as energy storage and smart home technology. So I encourage everyone to give PV Magazine a little bit of love. Check out their site and check out that article series. We'll try to link it somewhere in the podcast notes.
Yeah.
How about yourself?
Yeah, I found a good article that I was interested in. I'm a code nerd. I found an article in Solar Builder that was talking about a new code that I actually had not realized had made its way into the 2020 National Electrical Code, and it mandates that knife switch disconnects be secured, either locked or secured in a way that requires a tool to open them. And this might seem like a no-brainer, but there was no requirement for that up to the 2020 code, and it really increases safety for some of these boxes are placed in readily accessible locations with where kids can just go in and just be playing around and could stand a chance of getting really hurt. And so this just increases the safety, and I was excited to see that's new in our code in 2020.
Yeah, exciting times, and it's always great to see the industry kind of maturing what's expected of installers via the code, so that everyone who's interacting with these systems or has a chance to interact with these systems is as safe as possible when they're doing so.
Absolutely. Let's switch gears a little bit. We're excited to talk about one of the new products that we have coming. It's another new storage product, different than the one we talked about in last month's episode. It's from one of our manufacturing partners, BYD. They have a new residential storage product, and we got a chance to catch up with Devon Wilson from BYD, and he told us a little more about the product. So let's jump over to that conversation.
Yeah, let's check it out.
My name is Devon Wilson. I'm the sales director for North America for BYD for the battery box lineup of products. As some of you may or may not know, BYD is a very big company, and so one of their divisions is the battery box, residential energy storage products, and that's what I represent. But BYD is doing many things, many great things all over the globe in the US in many outlets. But BYD is one of the largest manufacturers of electric vehicles in the world. We don't currently sell those consumer electric vehicles in the US yet. But one thing we do sell in the US, which is a big part of our business, is electric buses. So that is all over the world a major part of our business. And that electric vehicle and electric bus business really informs our storage business. We've gleaned a lot from that industry since we've been selling electric vehicles for 10 plus years. We can lean on that knowledge as we roll out and develop new storage products.
So tell us a little more about the US market, residential energy storage in particular.
Yeah. So BYD, our battery box group, is relatively new to the US with our products. We've been around for relatively a little while all over the globe. It's about 2015. And we've been in Europe really primarily, as well as the rest of the world, but primarily in Europe, doing a lot of business and around for quite a while. So we built our brand quite a bit in Europe, Australia, the rest of the world. We actually came to the US fairly recently, and it's a byproduct of UL and the product divisions that occur because of UL regulations and things like that. So we're a little late to the US. But what we like to point out to folks as well, we're new to the US. We're not new to energy storage. We've, as mentioned, in other applications, electric vehicles, electric buses, we've been doing this for a long time. And then when it comes to residential energy storage, we've been doing that for a long time at huge volume with huge success in Europe. So we're here now in the US, been here for a little over a year. And what we've come with is our first product, which is our Battery Box HV, which is a high voltage residential energy storage product that is paired with a couple of inverters now here in the US. And we've begun sales, working with distributors and getting our name out there, building our name, kind of showing off our quality product and educating the industry from installers downward to consumers about the advantages of our product.
It's been really fun to see the growth trajectory that we've seen with BYD. Can you tell us a little bit more about what are some of those factors that you think are driving the adoption amongst our customer base? I mean, we've seen not only as the brand name has gotten out there, but as folks become more familiar with some of the features of the current HV battery box line, we've seen wider and wider adoption amongst our customer base. And we're kind of interested in your perspective on what's driving that.
Yeah. What we strive for when we created our product is to create a really robust, flexible product, right? So the trajectory we're on is we're having customers recognize that, especially in the US, with backup being such a powerful use case, it's something that everyone's asking for, right? Everyone wants backup. I think originally, and customers that are new to batteries, they kind of think of batteries just in terms of their capacity. How big is the battery? But I think people, installers, even down to consumers, are starting to understand what the difference is, different cell types, different chemistries, and different makeups of batteries, what that means when they talk about using it in their application. So our battery is really well suited for backup. And the reason for that is because of its chemistry. It's a lithium iron phosphate battery. And so what that means is we can push a lot of power in and out of it. And so when we're in the backup use case, when we're talking about that, you don't have the grid to rely on to power your loads. So you have to power everything from your battery or for your energy storage system, let's say. Then your energy storage system, which is composed of an inverter and a battery, at that point, whatever the weakest link is going to dictate how much power you get for your home loads. And so what customers see is when they take a given inverter and they pair it with our battery is not limiting them. And so it's just the inverter power at that point. And so I think as people start to understand how these different products behave when in these use cases, so in backup, for example, they start to see the advantages of our product. And we've definitely seen the progression of understanding among installers as they start to kind of see how different products behave in the field and then come back and try other ones and see how those ones behave. And they kind of get that positive feedback of seeing ours do great in some of these scenarios that maybe a rival product didn't do great. And so it's a very good kind of test house for us.
Sorry, my internet cut in and out. So I'm not sure if y'all already covered this. You gave a really great breakdown during the training yesterday of some of the benefits of working with LFP versus NMC based battery chemistries. Yep. And even vice versa. You kind of did both sides a bit of justice there. And I wonder if you could just kind of quickly summarize for our listeners today, what are those benefits of either side of that coin?
what I like to point out is that in the market, there's generally two types of lithium ion batteries being sold. There's NMC and LFP. And so different competitors offer different chemistry types, right? We focus on LFP products. That's not because that's the only cell we produce. In fact, BYD produces both LFP and NMC types. It was a conscious decision when we were going to create these products to say which is the best chemistry for stationary storage. And so what we did is we looked at kind of all the metrics. So as we just talked about, capacity is kind of the traditional metric we look at when we talk about a battery, but there's many more to it, right? So there is size and weight, there is power, how much power you can put in and out of it, there's safety, there's environmental aspects, and then there's kind of thermal considerations. What kind of temperatures can you use that product in? And so what the team determined is that when you're comparing LFP to NMC, LFP kind of outshines NMC in all of those categories except size and weight. And that's why most all of the consumer electric vehicles on the market right now, they use NMC. You can pack a little more energy. You know, in a vehicle, you put batteries in kind of in the base of the vehicle, and you need to pack a lot of energy into that space, and you're limited in how much room you have. So you want to use a high energy, a product with a high energy density. So BYD does it. All of our competitors kind of do it. NMC cells go into cars, and especially it's hugely important when you're lugging those batteries around. That size and that weight becomes hugely important because you're physically moving them, right? When we shift over to stationary storage, by nature of it, it's sitting in one place, right? So you install it and then it stays right there. You're not having to worry about size and weight. So while LFP doesn't outshine NMC when it comes to size and weight, we see that as less of a concern when we start talking about stationary storage. So we see that as an easy thing to kind of give up on a little bit, to have a little heavier, a little larger battery in that application because of all those other advantages that we see. So again, that's power. You can put more power in and out of an LFP battery. Ambient temperature conditions, so our battery can be used in a wider range of temperatures. It's a safer product. Why is that? Because it's more thermally stable. LFP doesn't suffer from a thermal runaway like NMC cells can tend to have. And then additionally, from an environmental standpoint, we're using more common elements, iron and phosphate versus nickel and manganese and cobalt. So we don't have a Prop 65 warning, for example, here in California on our product because we don't have those chemicals in our battery.
It's very interesting. Can you maybe say a little bit, because I think this runs true through both generations of the product, the current HV and the soon to be released HVL, that the way that you're able to stack the battery cells together and like design the product for the specific voltage that's required for a particular application allows you to maybe address some of the design issues that maybe we've seen with other options that maybe rely on other approaches to that.
Yeah, we designed the product to be modular and scalable. So it kind of stacks up. And this is, as you mentioned, true for the HV and the upcoming HVL, which will be kind of sold in parallel. But what happens is you stack up those modules, and through that, you're able to achieve different size batteries. So what that does, there's a couple of big advantages to that. One is just ease of installation. As mentioned, an LFP battery is a little bigger and a little heavier than an NMC product, but that's one of the ways we get around that issue is if you break up the battery into really manageable pieces, an installer can actually install our product easier. They carry it into site, they drop it onto the floor, and they stack it up. So what would be construed as a big negative, a heavier thing, we've actually found a way to kind of make it an advantage. And what we see in Europe is it is a huge selling point. In Germany, one of our biggest markets, we see many customers who rave about the fact that they don't have to worry when they get to site that they won't be able to get that battery where the customer wants it. You don't need to have 4 people carrying a 200 plus pound product down some stairs. You could break it into smaller pieces and one person could carry them down there and whatnot. So that's a big advantage. So then another aspect of our product, which is a little different than many of the competitor products, is we have a product that we call is true high voltage. So what that means is when you stack it up, you're getting, as you mentioned, you're getting different voltages based on how many you stack it up, but you're getting from 200 roughly to 400 volts for your product. And that's we say true high voltage because there's no DC to DC converter inside of our battery, right? So it's what some other battery manufacturers do is they take lower voltage product, say a 48 volt product. And they have a DC to DC converter, which boosts that voltage up to a level that the inverter wants, say 380 volts. So there's a couple advantages to not using a DC to DC converter and having a true high voltage product. The first is efficiency. So the closer you are to that kind of 400 volt operating range, the more efficient the system's going to be. And we've seen that from test data when we employ our product with a similar inverter and then compare that to a rival product with the same inverter, we see better efficiency. And that's just kind of due to not having to go through that DC to DC converter. Additionally, reliability, DC to DC converters tend to be a point of failure. And then lastly, in performance. So we've definitely seen this here in the US, but there can be some issues with DC to DC converters as far as switching from charging into discharging and the time it takes to do that. On the battery side of things, it can lead to some issues. So when we don't have that in our product, we don't have those same issues. It can really quickly switch from charging to discharging, which is hugely important when you're talking about a situation like an off-grid or sort of backup use case where you're off the grid at the moment and it might need to switch over from charging to discharging and rely purely on the battery in that case. So that's a situation where our architecture really allows the battery to totally shine and do some things that competitors can't.
Great, thank you. Let's talk a little bit more about the HVL. What features of this new line, and maybe you could give us a quick overview of the product before diving into the question, but what do you think is going to be most attractive to the homeowner?
So just to take a step back. So our existing HV product is, as we said, there's variable sizing for it, but it's 5 to 10 kilowatt hours. And in parallel, we're offering this HVL product, which is from 12 to 32 kilowatt hours. So first thing right off the bat is we recognize that there's a huge demand for storage capacity, especially here in California, but here in the US in general, when you're talking about backup. So we wanted to offer something that allowed for more capacity. And so the first thing a consumer is going to notice is they can add a lot of storage, right? It can go very high, especially when you pair it with, say, the Sunny Boy storage with 3 inputs. You can get a lot of capacity there. So you're really not limited anymore with the limitation on the battery side as far as capacity goes. The other nice thing is there's many stops, between 12 and 32 kilowatt hours every 4 kilowatt hour increments. There's many kind of stops on that you can do. So if you want a 12 kilowatt hour battery, a smaller one, you have that option. If you want a 20, 24, there's many, you can kind of tailor the exact sizing to what you need. But what we find is a lot of customers say, I don't know exactly what I need, right? I don't know that I need exactly 20 and not exactly 24. So one of the big advantages is you can kind of shoot for what you think you need, maybe aim a little small, let's say, and then add modules after the fact. So you're not locked in and say, ooh, I wish I had gotten that 24 kilowatt hour battery instead of this 20. You can make that change really quickly. All that takes is you take off on the top component, you drop another module on, and you recommission your system, and it's you now have a bigger battery. So we really like that idea, especially as installers and consumers who are maybe newish to prescribing storage sizes on the installer side and newish to the idea of how much battery do I need. This allows them to not have to overshoot it too much. They can try to go for what they think and then expand if they need to. And so that's one really big advantage. The other advantage with the HVL is we kind of rethought the whole process from manufacturing all the way up. And so what we were able to do is we were to reduce the footprint of the product and kind of make it a little better looking, reduce the size. So what you end up with is a product that takes up less space in your garage, say, while having more capacity. So a big increase is there on energy density, both at the cell level, but also the system level when we talk about the way we put modules inside of their casings and things like that. So you can opt for that really big amount of storage and not have it take up all your excess room in your garage that you want to use for all your other things.
Yeah, we're very excited to see that jump in capacity. I mean, I think that with all of the different battery technologies that we offer and all of the manufacturing partners that we work with, we're seeing that trend of larger options coming to market, options that when coupled with the right technology on the inverter side can come closer and closer to offsetting the vast majority of homes' use for general grid tied usage, and then doing quite a bit to support the home during any sort of a power outage or or anything like that. So do we want to go ahead and talk a little bit about some of the changes that your team identified and made when you were developing the HVL line? It was really interesting to hear about even some of the smaller seeming changes, kind of like changes to the body of the product to make fitting the units together easier. Other changes that I thought were really exciting, because I love when our manufacturing partners see their product being used a certain way in the field and get feedback about how it's being used, and then incorporate that feedback so that there's this real time kind of like loop of improvement and iteration that happens from application to design and then back again.
Yeah, no, definitely. And I'm very proud of the team on that front. As mentioned, we changed the way we manufacture the product, as far as not the cells. So it's still fundamentally the same cell manufacturing and all that. But as far as the physical product, what you see when you look at the battery box, the structure and whatnot. So we're now loading in the cell pack from the side rather than the top. And that allowed us to reduce some of the space that we need around there. Additionally, we changed the materials we used. We use an aluminum side plate now, a cast aluminum side plate. That allowed for rounded corners. It allowed for integrated handles, which just look better. It also, they rethought the way, because you're stacking these blocks up on each other, but you need some sort of keying, something to positively fit them together. And we used to use a pretty 3 pins essentially inside. But what they recognized, they could do that a lot better through these cast aluminum panels. So they fit together nicely, and it just looks a lot more quality. Just the way it comes together is a really thoughtful design. So all of those changes created a product that was more energy dense, a little more streamlined looking, and all of that. But additionally, they got a lot of feedback from installers and the way they interacted with the product when they were installing it. So for example, with our existing HV, you open up the top and you have access to it and you do all the wiring there. They changed that for the new product, so you access it from the side. It's just a little easier to see everything. Everything's kind of right there where you need it, pulled all to the front, and the installer kind of only has access to the things they need to access, and everything else is kind of hidden away. So it just brings the critical components to the forefront. Additionally, there's some safety advances. This is driven by the German market mostly, but little things such as when you take off that side panel to go make some wiring changes, it's automatically going to shut the battery off. It's something that all of our installers do, but we might as well help them out, and just in case they forgot, right? So that a little limit switch there to turn it off. So little stuff.
Any curious homeowners that start opening things that they
yeah, definitely. Like that, and then for the homeowners, we kind of thought about that as well. So we previously on our HV, we didn't have any kind of LED indicator or anything like that, right? It's got a breaker, which kind of is not very customer friendly. Let's say a big breaker hidden behind this protective cover. So what we actually added was a power button and an LED indicator. And so what the power button can be only used to turn it off. But if a customer needs to turn the battery off for whatever reason, say they call their installer and they say, "Hey, turn off the battery until I get there." Very simple power button that they can interact with that can turn it off rather than flipping some big breaker and feeling like they're going to cause some issue or something. So recognize that was valuable. And then the LED indicator just gives them information about their battery to tell them, yep, the battery's working great. They can already see on their inverter, indicators and interfaces and whatnot. This, they get some information from both components. And additionally, kind of that intersection of customer and installer, that indicator is used to kind of have a coded light system, so they can call their installer and say, "Hey, I'm getting, my battery's flashing 6 times. I don't know what's going on." Instantly, the installer can kind of know what's going on, come to the site armed with either spare parts or just knowing what needs to be done. So we definitely took stuff we saw in the field and tried to integrate it all, both from a customer standpoint and from an installer standpoint.
Yeah, we can't wait to get our hands on it and let our customers get to their first installations. Tell us a little bit more about how you're approaching, training and installer certification requirements and customer service.
Yeah, definitely. So when installing the energy storage system, the battery is really the easiest part. It's it connects. It sits behind the inverter, so it only connects to the inverter, DC wiring, communications wiring. So what we include when you buy our product is inside there's going to be something called a quick installation guide, which essentially has everything you need to know to install the product. And so we think it's a very straightforward product. So as a result, we don't require any kind of certification process. Of course, if you do run into an issue and a product issue or just you don't understand how to do the commissioning, you have a question, we have a support line. So you can call up. We have very short wait times, essentially negligible wait times. And we're always ready to support customers with that process. Just because, especially if it's your very first time, you maybe tend to overthink things a little bit and read too deeply into the instructions. But we think it's a very easy process, and especially with a little bit of support on that first install, we think installers will find that it's a very simple product to install at their future installs.
Did we already touch on the timeline for the SGEP listing, and what's the approach that BYD is taking to that?
We our HV is listed on SGEP's website. We'll do the same with the HVL. It's a process that you go through with them. It's important to note that for installers, being or pre-qualified or what have you on the SGEP site isn't a necessity to submit an application. Actually, you can submit an application with any technology you want, and then they'll kind of do the work on the back end to work with the manufacturer. Obviously, we're starting that regardless, but all that certification is underway as soon as the product's released, and we work with them directly to provide discharge tests and all those sort of things, so that the installer doesn't have to go through that process.
Well, great, Devon. Thanks for all this information. Really appreciate your time today. Look forward to working with you in this year to come.
Awesome. Thank you, guys. This was great.
That was a great conversation with Devon. 96 kilowatt hours. That's a lot of storage for a home.
That is a huge ceiling. And it's really exciting to see that they are designing their HVL product in line with their existing HV product line. The battery box HV right now goes up to about 12 kilowatt hours, I believe. And so this jumps in right where that leaves off, and allows folks that are interested in larger system sizes, anywhere from 12 to, like you said, 96 kilowatt hours of energy storage, to install that much on a single site is very exciting. I think that it really brings us close to that, whole home energy offset situation where folks are really only using the grid nominally and not really relying on it in the way that most people are right now.
It's nice to finally be there.
Yeah. And, as we were talking to Devon, I found myself kind of wanting to learn a little bit more about the requirements that feed into what battery manufacturers need to keep in mind as they're designing things and testing them to the standards established here in the US. I wanted to get a better feeling for things like, how does, NFPA 855 or UL 9540/9540A feed into the testing requirements and the product design that we see from our manufacturing partners. So let's go ahead and reach out to Matt Paiss over at Pacific Northwest National Laboratory and see if we can't learn a little bit more from him about these requirements and these standards and how they are applied to the storage technology that our partners like Devon over at BYD are working on bringing to market.
That sounds great. Let's do it. We're here today with Matt Paiss. Matt is a technical advisor for PNNL. He leads the Energy Storage Safety Codes and Standards Group. He also serves on a couple of UL committees, 1974 and 9540, as well as NFPA 855. So thanks so much for being here with us today, Matt. I wonder if to start off, if you could just give us a summary of the certification and testing landscape when it comes to energy storage equipment.
Sure. Yeah. Well, first of all, thanks for the invite. I appreciate it. I think you guys are doing some really great work out here. And, PNNL is a very large lab. Let me just explain to people a little bit. A lot of people have never really heard of Pacific Northwest National Labs. We're one of the 17 DOE-funded labs, similar to Sandia, Lawrence Livermore, Berkeley, and PNNL has about 4,500 employees and $1 billion research budget. So it is a very significant lab. It's also responsible for the Hanford reactor site, which is the very, very large cleanup operation. And so PNNL's efforts in energy storage, we have a number of different directorates from national security, nuclear, earth, energy and environment. And that's where the battery materials and systems group that I work in site. So just to give people a little bit of a background on PNNL, based in Richland, Washington. However, I'm a remote staff. I'm in the Santa Cruz office of PNNL. You can see it right behind me here. And so to get to your question about storage certification, there is a UL listing for energy storage systems, and that's 9540. It is in its second edition. And it is evolving I won't say very quickly, but there's a lot of changes in these last two editions. And I would say the landscape of that is still in its infancy. The larger energy storage systems that were installed just as recently as maybe 3 years ago had no listings. It has not been required until the emergence of NFPA 855 and the fire codes cite that. So typically what drives the requirement for certifications are the building, fire, electrical codes. And so we're just starting to see products that are coming from the manufacturers as listed. Prior to that, and on a lot of the kind of one-off designs, they get a field evaluation. It's different than 9540, but it does provide some of the evaluations, making sure the components are, listed for that use in there. So that's a brief explanation of it.
Yeah, so it sounds like we're kind of coming out of a bit of a wild west in terms of energy storage regulation. Do you agree with that, or?
Yeah, I think you definitely can say that's true in some installations, some locations. The industry is really trying very hard to install safe systems, and some of those safety best practices are reactionary. You have something that fails and you try and learn from it. And so, you don't want to be held to a single incident. So, the Arizona incident is the bellwether event for the industry because it almost resulted in a couple of fatalities. And there was much to learn from it. And we try and incorporate those experiences and best practices into the codes and standards. It just can take a while to get those codified and then to get manufacturers' products listed to that. And so that interim period can be a little confusing for some people.
So as installers are working to navigate through some of the new requirements that are laid out in the NFPA 855, what are some of the markings that they should be looking for in general? Is it just the UL 9540? Are there other markings that would apply to, say, the battery only or the inverter only that are specific to energy storage applications or energy storage systems?
Yeah, great question, Aaron. So to achieve a 9540 listing, that is a listing that's on the battery and the inverter. And depending on the design of the system, it could include the HVAC, if that's incorporated into it. So it's all of the construction of the entire energy storage system. And so when we look at a residential system, obviously there's not an HVAC. You may have some active cooling, but most products don't. And so it's really going to look at the unit itself. So an inspector is not going to look at a number of different listings. However, to get the 9540 listing, the battery itself has to be a 1973 listed battery. And that's the listing for the battery and any BMS that's part of that battery. So that's what separates it from a consumer tool pack or just a cell, because a battery can be one cell. So the 1973 listing, evaluates that battery pack. And then once you put together an inverter, 1741 listed inverter, then that really constitutes the bulk of the 9540 listing. The big addition is the 9540A testing. And that confuses a lot of people because even on some data sheets, you'll see where some people will say 9540A listed or 9540A certified. And those are not accurate terms. It's just gone through that test. The second edition of 9540 for the vast majority of installations requires the 9540A testing now. Whereas in the first edition of 9540, it did not require that because 9540A didn't exist at that time. And it was developed when the fire community was concerned about densities and spacings. And so we started to see some requirements in the fire code and in the first edition 855 that put some spacing requirements with the allowance of closer spacings based upon the results of large-scale fire testing. And so that was the first term that we saw. And then in the latest edition of the fire code, they actually call out UL 9540A as the test. And so on the residential side, which is a lot of the viewers of this show, the second edition 9540 does require the fire testing for really all residential wall-mounted systems. And so where we're at today is that very few have that. I'm only aware of one product on the residential market that actually has completed that 9540A testing and been listed to the second edition of 9540. So it's still pretty early in the residential storage market. There are products out there that should they have a catastrophic failure, we don't know what to expect from it, and could potentially result in a lot of damage. So I think that's the next step for the residential market, is to have all of those products go through that testing so we really understand how they perform under a catastrophic failure.
And just so that our listeners and viewers are clear, the 9540 standard kind of governs it's a general safety standard that applies to the energy storage system. Is that accurate?
A better way to say is it's the product safety standard.
Product safety standard.
Yep.
Okay.
And it's called out in the fire code in NFPA 1. When you're installing energy storage systems, they have to be listed. And because that is not included yet in the fire codes that are in place in most of the US, that's why it hasn't caught up yet to being a requirement.
Yeah. That makes sense. And so the 9540A, on the other hand, is more specifically geared towards making sure that we understand how the battery itself behaves, or how the energy storage system behaves in a thermal runaway event.
Correct. Yeah. The goal of it is to understand that under a catastrophic failure, and in the case of lithium ion, that's typically thermal runaway, a flow battery, a catastrophic failure could be a leak. So it's not solely for lithium ion. There is language to evaluate flow and even lead acid.
And mechanical as well, right? I believe mechanical
well.
storage systems also covered.
Exactly, yeah. And here's a key point. And this is not really helpful for current lithium ion cells, but there is a provision in the 9540A test which begins at the cell level and then goes to a module level, and then the unit or rack, and then an installation level if needed. At the cell level, if that cell cannot go into thermal runaway and not produce any flammable gases, then they are done with that test. They don't have to go on to the module level, unit level, because that testing determines what the fire, thermal runaway, and explosion risks are. And if there are none of the cell, then it's an off ramp and they're done. So, we'll see what solid state or other chemistries look like in the future. That test allows for a quicker certification path for those technologies. But for the current lithium ion cells, they do exhibit those properties, so they need to go through everything. And I don't know what your questions are, but I'm not sure how much to dive into 9540. Because there's so much confusion around what it is and what it does.
I would love to spend a few minutes diving into it, if you wouldn't mind. That was kind of what I was getting at with the question about, the basic differences between 9540 and 9540A. But I think that this is I almost expect that this will be a point of confusion for a lot of customers, especially if manufacturers are kind of, as you say, using the 9540A listing, I guess is how they would refer to it, to like almost imply that they somehow have a broader 9540. Yeah, if you wouldn't mind just spending a few minutes kind of like drilling into 9540 and making sure that our listeners and viewers understand what's going on with that requirement.
Sure. Yeah. To help people understand a little bit more about what a 9540A test consists of, like I said, it starts at the cell level. If it can go in the thermal runaway, produce flammable gas, then you have to evaluate the module. And the goal of the module is to prevent propagation. And so what the testing lab has to do is part of the requirement is to put a cell into thermal runaway. And so they wrap a heater all the way around the cell. And this is a change from the third edition of 9540A. So we're on the fourth edition of 9540A, and that it provides some clarification on how it's put into thermal runaway. So anyways, the layout of the module will determine how many cells do we want to mechanically heat to force a propagation of thermal runaway to an unheated cell. And so some module designs are really robust in their protections, and you might have to heat up multiple cells to get one to go in thermal runaway. And that in there lies some of the frustration of the manufacturers, because they say, well, we either have this active cooling system that doesn't allow them to get that hot, And we're not able to test utilizing those safety systems. And I think they have some valid concerns in some cases. But listeners should understand that the goal of 9540A is to understand a worst case scenario. So a internal cell defect is that worst case, because no BMS is going to protect against an internal cell failure. It could protect against overcharging of cells. But if you do have a BMS failure, and let's just say that you overcharge a whole string of cells, you could have multiple cells potentially going thermal runaway. So that's really why they want to see what happens when you do have a certain amount of failure. And it seems there's a little bit of artistic licensing that goes on in determining how many cells you want to put in thermal runaway. But I've seen up to 6 or 7 cells have to be forced in a thermal runaway to get one unheated cell to propagate. So that module test tells you how that module performs. But the other thing that's really important in it is how much gases are evolved and what happens, because sometimes you could have arcing and sparking as part of the thermal runaway process. And that tends to be a little bit more chemistry driven. Some chemistries have a much hotter reaction of that thermal runaway and produce arcing and sparking or fire right away. Others will just produce flammable gases. And you can have an explosion inside a module. And so that's another evaluation of it. And then they will take that. The next level of the test is the unit level. And that unit is really in the case of a larger system, it would be potentially a whole rack, or in a residential unit, it could be the whole residential unit with the enclosure as it's hanging on the wall or the ground. Mm-hmm. And they want to make sure there's no explosions, there's no flaming outside of the enclosure. And the other point that I'd like to bring up now is about chemistry, because one of the things that we see in this industry is manufacturers trying to differentiate their products. And we see some discussion around safety. LFP is safe, it's non-toxic, it doesn't have cobalt. And I think what's really important is kind of weeding between some of the marketing and some of the facts. And what we see in the labs is that there tends to be more arcing and sparking and flame from a cobalt-based chemistry than from the LFP chemistries. However, and this is really important for everyone to understand, all of them produce flammable gases when they're in thermal runaway. All right. So you may get all the way through the 9540A test with no fire that comes on the outside of it, because that is one of the tests, is they wrap it in cheesecloth and you can't singe any of the cheesecloth. And that's very difficult for some of the NMC chemistries. But if you have a manufacturer that uses an LFP product and they don't put out any fire, the test will evaluate the gases. And here there's a line in the 9540A test that says that, I don't know it by heart right now, but it's to the effect of the gases emitted, that the unit cannot be placed into a space that will result in greater than 25% of the lower flammable limit. So that's really key, because if that battery puts out a lot of gases and it's allowed to be installed in a very small space, you could end up with if you had a failure, you could have an explosive environment in that space there. So I think that's why it's really important that, especially in the residential market, because they are allowed by the code to be put in utility and storage closets. And so I think what we will end up seeing is the manufacturers in their installation instructions will have to do those gas calculations and say, okay, this battery can't be in anything smaller than 6 by 8 room, or they might find that you can't put it in a garage because it produces so much. So it's really important that they understand what that part of the test means. And right now I have not seen that in any manufacturer's instructions yet.
So yeah. I've got a question about a couple of the terms that you're using, because I thought that thermal runaway was meant explosion, but you're also using the term explosion. So can you explain the difference?
Absolutely. Yeah, great. Thank you for bringing that up. So let's talk about thermal runaway first. So thermal runaway is when the cell gets up to a certain temperature, there is a chemical chain reaction that starts occurring inside it. And as it's occurring, it's contributing its own heat that can't be dissipated through convection or radiation. And so it's a self-fulfilling cycle. What ends up starts to happen is that the electrolyte that's inside it starts to vaporize, and that builds up pressure inside the cell. And at some point, that electrolyte can basically be vented out of the pressure release valve. If the heating continues, then the separator between the anode and the cathode, when that separator, the first failure is it'll melt, and that will stop any electrical conduction, and you'll see a voltage collapse So when they're doing testing and they're looking at that, it's a telltale sign. You see voltage collapse just prior to full-blown thermal runaway, which is when that separator fails, you have a direct short, and now it's off to the races. There's no stopping it. Whatever energy is in there is going to be emitted with heat and gases. So some people feel that thermal runaway is just the emission of some venting, and it's not entirely accurate. It could happen very quickly. That window between some venting and full-on thermal runaway is different for different chemistries and different cell designs. Okay, that's thermal runaway. Explosions. So explosions or deflagrations, there's actually, on the technical side, there's deflagration and detonation. And that has to do with the speed of the flame. So if you look at TNT, that's totally a detonation. And that has to do with the speed and the pressure wave. At a slower flame speed of gases, you get what's called a deflagration. And that is the same thing as an explosion, but it's just a very technical term for the power of it. Hydrogen happens to have a lot of energy. So when you have a thermal runaway with a cell that produces a lot of hydrogen, then you're up on the upper scale, getting close to detonation there. So I don't know if that helps a little bit. The bottom line, anybody that's around one, it's a big boom, and nobody wants to be around it. We want to avoid them. We don't want to see any more booms in this industry.
Exactly. Do you have any other questions?
I had one quick one. So you'd mentioned, I think, in reference to NFPA 855 that the requirement applied to wall-mounted systems. And so I wanted to, get any information that you have about the different ways that the regulations or requirements would treat a ground-mounted versus a wall-mounted or ground-based system.
So let me just clarify. The 9540A test, you have to do the fire test on all the wall-mounted residential. The ground mount, depending on where it's located, you're going to want to know how much heat is emitted on the backside. So for example, we saw, LG, their new product, the larger one is a ground mount. So in that test, what they're going to look at, the ground mount test will allow fire to come outside the box, but it cannot, they're going to measure how, the wall that's mounted near, they're going to instrument surfaces around it, and you cannot have an increase more than 97 degrees C above ambient. So they're going to evaluate those, but that will be very likely, I predict, a more common installation for the cobalt-based batteries, just because preventing against fire is really difficult to do. So that we'll see what some people are able to design into their system to prevent fire coming out. But I was interested to hear that that's how they're mounting that one. I think that's kind of their way of meeting those requirements.
So before we go, Matt, is there anything you're working on or want to tell us about, let our audience know about?
Yeah, pretty exciting. So one of the big gaps when you look at some of the larger energy storage systems, not residential, more commercial and utility, is explosion prevention. And one of the real challenges is having it exhaust gases fast enough. Some of these cells, when they go into thermal runaway, they put out a lot of gas very quickly. And so typically these systems will include deflagration venting. Those are blowout panels. So it doesn't stop the explosion from happening, but it tries to prevent it from destroying the building or injuring somebody. Well, one of the things that PNNL is introducing is some technology that we're licensing that is a passive exhaust system for cabinet-based ESS. And that's the direction that a lot of these larger systems are moving towards, is an exterior access. You open the doors and the battery's right there, away from the container base where you walk inside a man door and service it inside. And so when you have a smaller volume, it's even more difficult to exhaust it. And so, we have a technology that's called IntelliVent that we're starting to release and share with different stakeholders. And we think it potentially offers a good solution for those cabinet-based ESS. So that's interesting on the horizon there.
Very cool. Thank you so much for being here, and we hope to talk soon.
Thank you so much for the invitation. This is my pleasure.
Well, that was a great conversation with Matt. He's such a knowledgeable guy. I was excited to learn about the difference between a thermal runaway event and an explosion. These are technicalities that I wasn't aware of.
Things go boom, explosion, things kind of fart, thermal runaway.
Exactly. Well, since we're on the topic of storage, We recorded a conversation last week about our new storage comparison chart. I think we should jump to that conversation right now.
Yeah, let's check it out.
Aaron, so for the podcast listeners out there, what are we looking at? What combinations does this feature? I'm seeing Solar Edge, Enphase, BYD. Can you walk us through it?
Yeah, sure. So for any podcast listeners, I encourage you to go to our website when you have a moment to look at our magazine and see this document for yourselves. We're talking about a PDF document that includes a table that shows the various storage options that we offer and that are available more widely in the market at the top. And then below each of those options in a column, we have each option broken out by certain attributes. So we look at the specifics of the product combination, what inverter and storage combination are we talking about specifically? And then we take a look at some of the tested performance data, the SGIP result, the SGIP testing results to compare what we saw come out of those tests for each of these options. And then finally, we take a quick glance at a couple of different widely desired product functions and more broadly at product specifications to allow folks to compare the way that these different options stack up to each other. So what we decided to do here is look primarily at the options that we have within our product catalog. So we focused on the Generac power cell system, the Enphase InCharge system, the SMA Sunny Boy storage paired with either the LG Energy Solutions Resu 10H battery or the BYD battery box solution. And then finally, from our product catalog, we also have the LG Energy Solutions plus StorEdge Energy Hub as a point of comparison. So we lined each of those options up, and we also tried to grab data from the Tesla Powerwall as well to compare our options to other options that are available out on the market.
So I'm noticing right off the bat, SGIP. Let's talk a little bit about that. What's that?
The SGIP is the self-generation incentive program that California established a couple of years ago to encourage both residential and now some commercial storage installation to support various renewable energy portfolio goals. The SGIP program is a California, essentially like a rebate that folks who install solar energy systems in line with the program requirements can take advantage of.
And so those numbers that we have there, how do they get there?
Sure, yeah. So how did we get the numbers? We got the numbers from SGIP testing data. So one of the aspects of the SGIP testing program is that they've established a verified equipment list for equipment that they put through their own series of tests to understand how it's going to perform kind of under expected conditions, right? So the tests kind of spell out the standards by which the products are tested, and the results of the test spell out the overall verified SGIP energy storage capacity, the SGIP verified system rated capacity for AC output, and then the SGIP verified system duration at the max AC output. Gotcha. So yeah, the story that these numbers tell us is how much energy is going to be accessible when you're using a battery inverter combination to support home energy storage. And then of that accessible energy, how quickly can that energy be discharged for a customer who's needing to use that power at its maximum output for a certain duration? And so, yeah, that final number is the duration. How long does the system take to discharge the battery to the full capacity to no capacity?
Gotcha. Now, one thing that I'm noticing is that we have some products that are going to be coming out soon that aren't on this list.
Yeah, it's true. I mean, the residential storage product landscape is one that's changing very, very quickly.
Like the solar industry?
Just like the solar industry. Yeah, we're going to have to expand the solar coaster moniker to include storage, solar and storage coaster. You know, we even just this week found out from one of our main manufacturing partners that due to broader shortages within their bill of material and product components, there's a global shortage that's affecting one of those components that's going to affect their ability to get us some of our orders on time as expected. And, what we might see is that, we find that folks are in a situation where they're going to be forced essentially to switch to a different battery in order to support previous home energy storage sales that they've had customers sign for.
Oh, that could cause a headache.
Yeah. It's not fun in some cases to kind of be close to the bleeding edge here. And so the end result of that is that, what was already true about this document is especially true right now. We're going to be looking at this as a living document that needs regular updates. So we'll be adding additional options as they become available. You may see options disappear from the list as, those are no longer available from within our inventory or more broadly within the market. So it'll be important for anybody who's wanting to stay on top of what's happening in the residential home energy storage market, from a product perspective, to check in on this document frequently and come back and check out the updates that we make as we're trying to make sure that our customer base is as well informed as possible about what's going on in this part of the market. What folks will find is that there are different performance characteristics for each of these options. And, that combined with the feature sets, I should say, that are specific to each of these product lines is really going to help guide our customers in finding the energy storage solution, both battery and inverter combination that's right for them, for their sales teams, and for their customers.
Sure. Is there anything else you want to point out?
I think what I would add is just that if folks are curious about where these numbers came from, how other options that are not listed here compare to the options that we do have listed here, a lot of the information can be found on the SGIP website as well. If you go to the SGIP incentive program or the self-generation incentive program, the SGIP page, there's a verified equipment list, and there's a few different options. There are integrated systems that are listed separately from paired systems. And then again, you have separate listings for each of the battery and inverter options that are available on the market. So there's lots of great data there for folks who are interested in doing a wider comparison with maybe some of the products that we don't offer to understand and identify what's going to be best for their customers.
So just real quick, for an integrated system, that's something like Generac or Ensemble that the inverter and the batteries are made by the same manufacturer?
Yeah, that's exactly right. Right now on this list, the integrated solutions that we're showing are Generac, as you said, the power cell options, and then the in-phase in-charge system that's going to be part of the Ensemble broader solution set, are both of the solutions that we offer that come from a single manufacturer. On the list is also Tesla, and Tesla is arguably also going to be an integrated system as well. Oh, man. It's always good to hear from us, right, Kate?
That's a great document. I'm really excited about it.
It was a lot of fun to put together, and we're really interested in getting feedback. We are going to have to be modifying that document regularly as new products come to the fold and new partners enter the arena on our side, right? So watch out for revisions of the storage comparison guide. We'll be adding additional manufacturers, more information from SGIP as we have it, so that everyone can continue to compare these options and opportunities as they need to.
One thing I want to say is that if any of our listeners out there have topics that they'd like to learn more about, please let us know. In next month's show, we're going to be talking more about policy. We've got a change in administration that just happened, and that with that comes a new outlook for renewables. And so we're going to take some time and dig into what some of those new policies are going to look like for our industry.
Yeah, it'll be really fun to explore the impact of the Biden administration on renewable energy portfolio standards, as well as incentives, right? We saw the federal income tax credit extended I believe at the end of last year. So even before Biden was sworn into office. And I'm sure that there will be other policy changes that originate with this administration that will have a significant impact on both the industry as a whole, but then also on what's going on at a local level for all of our installer partners out there.
Absolutely. Well, thanks everyone for joining us. We'll look forward to chatting again next month.
Yeah, see you next month.